Okay, so for the second part of chapter E, this is super important, and we're going to talk about significant figures in our measurements. So, like I said before, every measured number has a unit and a number associated with it. So, we're going to look at how many actual digits that we need to have there to abide by what we call our significant figure rules. Now, there's two types of numbers. There's what we call a measured number and an exact number. A measured number is simply that we measure it, or we are told it's a measured number. And the measured number has our digits along with our unit. Then we have what's called an exact number. An exact number is something that we count, for example, and it's also one of our conversion factors. So, and for example, for every inch, there's 2.54 centimeters. This is a conversion factor. It allows us to go between inches and centimeters, just like there's 12 to every 1 dozen. Those are what we call exact numbers, and they don't end up playing a part in our significant figure calculations. So let's talk real quick about significant figures, and we're going to go over some rules. And the rules are based around zeros, the number 0. So here are the rules to be exact. So, all right, we're going to start with non-zero digits. So anytime we have a number that does not have a 0 in it, all of those numbers are going to be significant. For example, 536. 536 has 3 significant figures. If I have, let's say, hold on one second, let me make sure I can get this up here. Your option. If I have the number 4,171, how many significant figures would be in that number? The answer is 4. 1, 2, 3, 4. They're all non-zero digits. Okay, so that is rule number 1. Rule number 2 is that when I have zeros, that what we call trailing zeros, they do not count. So a trailing 0 is in a non-decimal number. Okay, so go ahead and write that down. Trailing 0 is in a non-decimal number like the number 400. So the trailing zeros are zeros that come after a non-zero digit. So these zeros here are not significant. However, the 4 is, because it's a non-zero digit. So this number here has 1 significant figure. This number here, if I had 530, how many significant figures would be there? It would be 2. So I have a non-decimal number with trailing zeros. The trailing zeros are simply just placeholders. So for example, if I had 53,000, how many significant figures would be there? The answer would be 2. These would be trailing zeros. Again, this is true for non-decimal numbers. Okay, so that's rule number 1 and rule number 2. Rule number 3 is now we're going to talk about the zeros in front of a decimal number and those that go behind it. Here's what I mean by that. All right, so when I have a decimal number, these zeros here, they're just placeholders. So the zeros at the beginning of a non-decimal number do not count for significant figures. However, these 4 do count. Of course these do because they're non-zero digits. In a decimal number, trailing zeros do count, whereas in a non-decimal number, trailing zeros do not count. So in this number here, I have 1, 2, 3, 4 significant figures. These two are just used as placeholders. So let's say, for example, I had 0.00014. How many significant figures would there be? The answer would be 2, because these would be what we call leading zeros in a decimal number. They do not count, they're placeholders. And then, of course, our non-zero digits count. If I change that number to 0.001400, now how many significant figures do I have? The answer is I have 4. These are placeholders, my leading zeros, and then these do count. Anytime, again, you have a decimal number and a 0 comes after a non-zero digit, they do count. Okay, let's go down here real quick. So when we have something in scientific notation, and we will be using that quite a bit, the same rules apply, but it applies to this part, not the exponent. The exponent won't count at all for significant figures because the exponent is just a placeholder. So for example, here we have a decimal number, and I have zeros. They're trailing zeros, but they come after a non-zero numbers. They all count. So I got 1, 2, 3, 4. 4 significant figures. Then here, it's the same sort of idea. Our exponents aren't going to count for significant figures because they're just placeholders. And then I look here, I got a decimal number. I do have some zeros that are trailing, but because there's a decimal number, if there's a non-zero digit in front of them, then they count. So how many? We have 4. Okay, let's practice this. So I'm going to ask you to take a moment and maybe pause this and go ahead and make your way down to see how you would do, giving the correct number of significant figures. So I'll give you that for a second. Pause it. Okay, so here we have leading zeros. They do not count. So I have 2 significant figures in this number. Here I have all non-zero digits, so they're all going to count. I'll have 4 significant figures. 1600 is, there's no decimal, so these are trailing zeros. Because there's not a decimal, they do not count. So I have 2 significant figures, which is just these 2. This one, decimal number, I have leading zeros. Those are just placeholders. So my only significant figures here are those 3. All non-zero digits, so I have 4. Okay, 100,000. So 100,000 with no decimal means that these are trailing zeros and they are just placeholders. So the answer to this is 1. I have 1 significant figure. Here, I have a decimal with some trailing zeros behind a non-zero digit, so all 4 of these count. This one, I have leading zeros and a decimal. They do not count. And then I have 3 significant figures. 500, again, no decimal, so they're trailing zeros. They don't count, so I just have 1. Now this one is meant to be a little tricky. Here I have a decimal. So that decimal tells me that anytime I have a 0 that has a non-zero digit somewhere in front of it means that it is significant. So in this case, I have 3. Okay, so significant figures is going to be super important as we move through the semester because all of your problems are going to have to be to the correct number of significant figures. Okay, so when we make a measurement, we need it to be to the correct number of significant figures. So let's say Oh, wait. Shoot. To be precise, and as you can be precise but not accurate, every measurement has some sort of uncertainty to it. And that uncertainty lies in what we call the estimated digit. And we're going to talk about that here in just a minute.